All right, folks, we are almost done with the definition section of this method. Phew! I mean, what a journey this has been, right? So if I go back to the top, internal standards are to check the equipment to make sure they're injecting the right way. Surrogates are basically things that we're adding to it that aren't supposed to be there. So that way we can make sure the machine sees that and we're getting a really good response from the equipment and from the method processes. The laboratory duplicates are there just to make sure we can put some precision or standard deviation behind the lab workers. Field duplicates are there. That way we can put precision or standard deviation against the people that go out in the field and collect samples in this case. Laboratory reagent blanks, we're making sure that the blank is actually a blank and there's no signal that's assigned to it and it's not interfering with anything. The field reagent blank, again, it's a blank that travels along with the field collector and comes back into the lab. This is just to make sure that all of the transportation and the storage and collection is done the proper way. There's no interferences. The lab performance check, we said we make it, we run it, we make sure that the machine's showing what it should be. It could be one or it could be many things that we're looking for in the method. 3.8 is a fortified blank. So again, the idea of a blank is a blank. There should be no signal. We add what we're looking for, and we hope that we see that proper report show us that value. And then 3.9 is the fortified sample matrix. So we run a sample, we get a number, then we take that sample and we add some stuff that we're looking for to make the signal go up. And hopefully when we run that, our signal will go up accordingly as expected, right? 310 is our standard stock. 311 is the primary dilution piece. 312 are the calibration standards that I will make from that. And then 313 finally is a quality control sample, or QC is what we call that in terms of a lab. So let's take a look at this definition. It says, a solution of method analytes of known concentrations which is used to fortify an aliquot of LRB or sample matrix. The QCS is obtained from a source external to the laboratory and different from the source of the calibration standards. It is used to check lab performance with externally prepared test materials. Okay, so what is this, Tracy, definition-wise? QC sample, or QCS, is what we're going to focus on in this video. Folks, it's very simple. This is a process that we use to check you. Oh no! Me? Why do I want to be checked? Why am I on the line? Because you're doing the testing. You're doing the sample prep. You're doing the reporting. You're analyzing the numbers. So we want to make sure that you are actually doing your job the right way. And we want to make sure that you're going into it kind of blindly. That's the purpose of QC. So this is you being blind because this is a unknown concentration, but only to you. Because if you go back and you look at that definition, it does say that the lab preps the QC sample. But it used this word external, which means that you're not prepping it. Because if you prepped it, that would be the lab performance check. We already talked about that definition. You did it. You added it. The SOP told you to add this amount to this. Shake it up. Mix it. Put it on the machine. Get a report number. Right? I mean, it told you like straight out. This is what you need to do. This, though, is a little different. And this is not prepped by you. And it's often kept a secret. Someone external of the lab has prepped this sample. And they have given it to you. And they have probably termed it as QC when they've given it to you. Or, if the quality control group wants to be really dirty, they don't have to use the QC on the code. They can just give it a random sample ID number, and you don't know any different. So they throw this QC into the sample, and they give you this batch of samples. and they say, run them. At some point in there, one of those samples is a QC sample. All right. One of those, maybe, and you won't know which one, maybe not, maybe, but maybe not. One of those samples will be a sample that has been prepped by the lab outside of the people that you talk to, outside of your coworkers probably. And that concentration is kept secret. That's the key here. And what happens is that you will process this sample and you'll get a report number. You'll get a value. And you'll kick that value back to the QC department, and that QC department will question it, and it will say, do they pass or do they fail? So the lab performance check is a way that you can make a sample and check it and know what to expect, and cross your fingers, hopefully that number comes back really good. Then the QC department will throw in one that they will make, and you won't know the concentration of that one. You'll run it like all the other samples, process it like all the other samples, get a report like all the other samples, and there'll be a number attached. And you give that report value back to the QC department. And the QC looks at that and they say, yeah, this is really close to what it should be. Great job. Good for you. Keep on trucking. Keep on processing those batches of samples as we send them your way. Or they're going to look at that number on the report and they're going to go, wait a minute. This does not make any sense at all. This is what the value should have been, and you gave us this. What on earth? I mean, there's not even anything close here. So something messed up. And if this fails, there is a chance that your entire batch will also fail. And that means you've got to reprocess and rerun everything. That's why, oh God, the QC failed. The QC people are walking down the hallway in their little bitty clipboards and they're going to tell me that I've done something wrong again. That is part of it. But it is their job as somewhat oversight to make sure that quality is built into the system. And that's actually what all of these are. It is quality that's built into the sample batches to make sure that the numbers that we're generating here are valid and they're scientific, and we've got some proof in the pudding on what our values are meaning and what they're telling us. So the QC sample, QC is typically what we use in our lab for this, or QCS. This is made by someone else other than you. And it has a known concentration to them, but it's an unknown concentration to you. All right. The concentrations are going to be different than the calibration standards. Most of the time they are. Calibrations kind of stand alone. They do their own thing. Not anything, everything else should be different from that. But this is something that the QC department will make that judgment call on. They will make it. They'll determine what value or values are appropriate, and that's what they'll start providing their lab workers. It's often made from a different source. All right, so for instance, let's say that in the last video we talked about 1,000 part per million iron standard stock. So this is something I've ordered, something that the lab has, something that the lab uses to make their primary dilutions with, right? Okay, well, the QC will have maybe their own bottle. And that bottle comes from maybe a different batch. It comes from a different supplier. It comes from a different brand name. Whatever the case is, it's not coming from the same bottle that you have used. This is another way that we're putting quality into the system. So QC has their own area. QC has their own stuff, and it is going to be different than what you are using in your lab spaces. All right, so it's a different source than the other standards. Next, it is encouraged that the QC is made from someone external of the lab. So they don't really have any ties to the lab workers in that area. They don't really talk to them. They don't really, it's not a coworker. If it is a coworker, then they just don't share the information. They don't tell the lab workers what that concentration should be. That is part of the QC. That is one of the definition requirements, right? It should be unknown to the person that holds and processes the samples. That's what this is all about. So if it is someone that works alongside you in the same room, you shouldn't go to them and say, "Psst, hey, what's that QC sample? Could you tell me what that number is before I send my report to the QC department? Because if I send another report to the QC department and my QC sample doesn't work quite well, then I might get fired because this is my 20th time that it's not worked. So could you let me know what that is before I send it? No, that's not how this works. All right. And then next, the purpose of the QC is to double check your work. That's what this finally is. So we've double checked the blanks to make sure they're not interfering. We've double checked the method processes to make sure they're not interfering. We've double checked the sample matrix to make sure it's not interfering. We've double checked the field collectors to make sure they're not interfering. We've double checked the equipment to make sure that's not having something weird or wonky that's going on. And finally, we're now double checking you again in a different way with the idea of a quality control sample. Whew, what a mess. Now, here's the story with this. Everything that you have learned about so far in the definitions, all of these QC, and I'm just going to put these in parentheses because they all go by different names, not QC abbreviations, right? But this as a whole is what we would call QC standards. Our lab blanks, our lab matrix, our fortified blanks, our fortified matrices, our surrogates, our internal standards. Everything about those definitions, it's built quality into the system. So as a whole, we often call these the QC standards or the QC batch, right? Even though only one is actually labeled as a QC sample, we know that, but everything else has ties to quality as well. So this is general lingo that goes on in a lab, and I just don't want you to get confused with that. Yes, there is a sample. Yes, that sample is dedicated quality control. Yes, that sample should not have a concentration that you should know. You'll run it, you process it, you report it back to the QC department. Great. I'm not telling you any different. But all of these definitions that we've talked about, the majority of them at least, it falls under this broader term that we call a QC standard or a QC batch. The batch has various QC standards. These are standards and things that we've prepped to ensure quality is built into our lab procedures and our lab methods. That's what this is. So people get very loose on the terminology, and I'm just pointing it out there like, hey, this is a thing. Don't be surprised if people start talking this kind of stuff, and then you get confused and you're like, wait a minute, I thought quality control sample was just one sample. Why are they referring to everything as quality control samples? Well, they're not. Quality is used there as an overall umbrella term, but QC sample, quality control sample, is really just for that one thing that the QC department is giving you to run along with your samples as you process them. All right. Also, all of these, if any of them fail, what happens? Right? So let's say that the blankets ran and it fails, or my surrogate runs and it fails, or my fortified samples run and they fail, or my calibration standards run and it fails. What goes on? If they fail, there's different options here. That depends on the SOP, and it depends on what part does it fail in. And there is a chance that you have to repeat and you have to remake maybe everything. Now you see the problem with quality control, right? If you get the bad news and one of these things don't quite work out the right way, they're going to let you know about it. And they're going to say, listen, this is not working. What you reported doesn't quite make sense across the board, and we had some issues here, and we got to figure out what those issues are. There is a chance that a piece of your batch will pass. There's a chance that maybe half of your batch will pass, but there's also a chance that you will have to repeat and remake everything depending on what goes on and the results that the QC department sees. And nobody wants to be that person. Nobody wants to be the person that has to tell somebody else, oh my God, I got to go back and redo it all over again because I didn't do it right the first time through. Okay, so now we're getting a little bit more red tape. We're seeing what goes on in a laboratory space. We're seeing what goes on more or so in a quality control department and quality assurance in a way. And it really houses here in this section that's called definitions. Now, in the upcoming videos, they might be a little bit older for you, but in the upcoming videos, I'm going to go through and talk about the other areas of a method. And this will include the interferences and the safety, the procedure steps, and everything else. You're going to see this in some of the other videos. I'm going to skim through a lot of it, though, because we're not looking at details in these areas. We're not trying to memorize other terms or figuring out what this method is actually doing. It's just highlighting the different sections and talking about what those different sections' purposes are. And that's what you're going to be seeing in the upcoming videos, okay? So keep that in mind, and then sooner or later I'll see you back, and we'll wrap up the method piece and go on to a standard operating procedure and talk about a little bit more details of what goes on when a company does modify a original method and gives it to you as a laboratory worker later on in the process.